Today we are again drawing different curves. We have drawn some easy polynomial type of curves last lecture. So let us begin. First graph is y is equal to x upon 1 plus x square, and you have to draw it for all values of x. That is, x belongs to real numbers. Okay, give you some time. Okay, now I have to explain this, and it is interesting because is this function undefined anywhere? No. For every x, denominator never becomes 0. So for every x, value of y is available. Okay, in this I can say you need to check if f is even or odd or nothing. Now in this case you will find if you replace x by opposite of x, then the sign of y changes. The value is same, y sign changes, therefore it is odd function, and therefore our 50% job is reduced. The moment either you get the function even or odd, you need to sketch only 50%. In this case, if we sketch positive x-axis, we need to reflect positive x-axis in origin because the function is odd. So this is yet another thing that you might check. Okay, what are the, so you find out y dash equated to 0, you get maxima minima, I think it is plus or minus 1 is equal to x. So these are the two maxima points. You can find the value of function. When x is equal to 1 it is 2, when x is equal to minus 1 it is minus 2. So the extend means the range is not r, the range is much lesser than r. So maximum value of the function is plus 2, minimum value is minus 2. If we substitute x is equal to 0,
minus half.
bolo Harshita.
It should be half and minus half.
Plus and minus half. Okay. If we put x is equal to 0, function becomes 0. Therefore, yes, this point is part of the graph. We can say limit x tends to plus infinity. If limit x tends to plus infinity, what is the value of y? You divide everything by x square and y becomes 0. So as x tends to infinity, your curve is going to be like this, positive. X tends to positive infinity, y tends to 0 plus. 0 is for plus side. If x tends to minus infinity, y tends to 0 minus. So it is like this. Now here I would like to say that I am drawing this small arrow here convex. It is up, opening up. I am drawing small arrow here which is concave. Slight concaveness. Okay, that is how it is going to be. Because if suppose this is my y-axis, and if I have, as x tends to infinity, if I have concave function and my points of inflections are much to the left, then it is bound to intersect unless you have point of inflection after this. Okay, so that is what is happening here also. I mean, this is point 1. So you achieve maxima at point 1 and minima at minus 1. Okay, it passes through 0. It is continuous. Therefore, now this is convex up, convex down. I mean, as far as calculations are concerned, you should complete it by doing y double dash is equal to 0, and you get x is equal to 0 root 3 and minus root 3. These are the three important points where the point of inflection is taking place. So First inflection is at 0, second is at root 3. So here maxima is achieved, therefore you have to bend this graph down. So now obviously before doing calculations also you need to know that there is going to be a point of inflection, because if this concavity continues then it cannot be asymptotic. Therefore there will be one point of inflection. After one, maybe we can say it is at root 3. My sketching is not good, some problem somewhere. Okay, so that is how the nature of this function in positive x-axis. You need to reflect it in origin to get it into the negative x-axis. This is minus root 3, and therefore we could sketch this one. Actually, it is a linear upon quadratic. Linear upon quadratic. So I think all the techniques and tools that are required to sketch are now being demonstrated. Maybe if you want, I can list them. First thing is critical points, in which one y is equal to 0 at which x values. 2, y undefined for which x values. 3, points of inflection. 4, maximum, minimum. 5, any critical point, any more critical point that we can have. Okay, if you have found out all the critical points, then take limit 1. How do you take limit? X tends to plus infinity. Second, x tends to minus infinity. Third, left of undefined, left of point where y is undefined. Y undefined at x is equal to c, for example. X tends to c plus, or x tends to c minus. So that is the second thing that you are supposed to do. Then you are supposed to do at least two derivatives. Find y dash. Find y double dash. Now find y dash, find y double dash will only give you some of these critical points. So these are the procedures. Extend. So find max y, max min y. Convex, concave. All these things need to be done every time that you are sketching, and that makes our job easier. Okay, the second problem which I had given was 1 or 2, which you can complete it very quickly. Y is equal to mod x upon 1 plus x square. Now, have you already sketched this? Then you show me.
Sir, critical points can also be like discontinuity and undifferentiability points, right?
Yes. Okay. Discontinuous and 6 not differentiable. Good. Sketch this mod x upon 1 plus x square and show it to me. Where is it? Okay. Sketch. It is as simple as first one. You sketch it for positive 0, 1, root 3, and you just reflect it minus root minus 1 minus root 0. Point of inflection and this value is half. Done. Third, x square upon 1 plus x square. Sketch and show. Resume. Same, all of these tools, when we apply, we come to know that there are 2 points of inflection. The function is even because if we replace x by opposite of x, y value does not change. There are 2 points of inflection, 1 upon root 3 and minus 1 upon root 3, and eventually as x tends to infinity, the value of y becomes 1. As x tends to minus infinity, value of y is also 1. So dotted line at y is equal to 1. That is the maximum value this function can achieve. Actually, it will not achieve. It is asymptotic. So this is 1. This is 1 upon root 3. This is 1 upon root 3. So at this point, it is going to be asymptotic. So from here to here, it is going to be convex. Now you cannot continue convex like this eventually because it will cut this line. Y is equal to 1 line. It will cut if it is it is not becoming concave. Point of inflection is not there, and hence it is there and it becomes concave down and becomes asymptotic. As it is symmetric, it is going to be looking like this from left. This is 1 upon root 3 with negative sign, 1 upon root 3 positive sign. This is 0. At 0, tangent is horizontal, that is x-axis. That is how you can decorate this figure. Now, can you get me quick sketch of 4 y is equal to 1 upon 1 plus x square. Get me quick sketch of y is equal to 1 upon 1 plus x square. Okay, so the graph for this function is like this. Minus 1 upon root 3 plus 1 upon root 3, 0, this is 1 and asymptotic. So if we rearrange this, what do we get? X square plus 1 minus 1 upon 1 plus x square, which is equal to y is equal to 1 minus 1 upon 1 plus x square. So if we know the if we know the graph of this function, that is this, we want minus 1 upon 1 plus x square. So reflect it in x-axis, it will become like this. This is minus 1 upon 1 plus x square. And so pan it up by 1 unit. That is what is this graph? Pan it up by 1 unit. Okay. So there is a similarity in the graphs that we are drawing today. It's a linear upon quadratic or quadratic upon quadratic or constant upon quadratic. That is what we have done. Now, the first graph was x upon 1 plus x square. Actually, I have not tried this and therefore I would like to give it to you. First graph was y is equal to x upon 1 plus x square. If I say x minus 1 upon 1 plus x square, whether it becomes very difficult or it becomes easy, spend some time and find out. So x minus constant upon 1 plus x square, if we can establish the general result like that, it will be great. Therefore, I want you to sketch 5 and compare it with 1. The graph of this function is very complicated. The moment you make small change here, the graph becomes complicated, but as we have given it, if you take first derivative, I think you get to 2 critical points maximum in a minus 1 plus root 2 and minus 1 minus root 2.
Or 1 plus minus root 2.
1 plus minus root 2. Is it true? Yeah. 1 plus root 2 will be little away. 1 minus root 2 will be little closer. So eventually the function becomes maximum here, passes through 1. When x is equal to 0, y is equal to minus 1. When x is equal to 1, y is equal to 0, the function will go like this. It will attain its maximum at this point and then becomes asymptotic with respect to x-axis. From here it will also be asymptotic. So practically I am not sure whether you are able to find out the points of inflection or not, but there will be one point of inflection here somewhere down the line here. This is convex, 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 and somewhere in between, either here or somewhere, it becomes concave, and there will be somewhere else. So there will be, I think, 3 points of inflection. But then second derivative calculations become long, but if we meticulously do it, we will be able to. But there is no symmetry. I think symmetry we have destroyed by doing this. So, okay, that was purely academic. Let me give you the next problem. Little different. 6. Y is equal to e raised to minus x square. Sketch. Do everything. Eventually the graph is going to look like this. Point of inflection at plus 1 upon root 2 and minus 1 upon root 2. Maximum value of the function is 1. So from here to here, concave differentiability yes at x is equal to 0. From here onwards it is convex. Right? I think you will get this very quickly. Okay. Now let me give you seven. Y is equal to, now quadratic upon quadratic, x minus 2, x minus 5, x minus 1, x minus 6. Sketch. So the graph for this is like this. Y-axis, x-axis. Of course, it is undefined at x is equal to 1. and x is equal to 6. Oh, I should not have drawn y-axis like this. At x is equal to 1, it is undefined. 2, 3, 4, 5, 6. At x is equal to 6, it is undefined. Now, as you do further analysis to the right and to the left of 1, you will find convex going this way. To the right of 1, you will find concave going this way. To the left of 6, you will find concave going this way, minus infinity, and it will go to plus infinity like this. As far as limit as x tends to infinity is concerned, what is the answer? X is equal to y is equal to 1. That is where it will stabilize. So this is my 1. Y is equal to 1 is yet another dotted line where it is. The value of the function is going to be asymptotic. That means it will not be achieved for any real value of x. And because you are above a y is equal to 1, here you will continue to have it like this, convex up. So practically you need not have to worry about it, and maybe you can join this. Okay, this way also it will go to minus infinity and you can join this. Okay, so now to the left of 1 is done, to the right of 6 is done. You are supposed to take care of something between these two. So first derivative equate 0, you will get x where it is maximum, and you will find that the value of the maxima is less than 1. Therefore, you can find out for x is equal to 2, y becomes 0. So the graph will pass through this, x is equal to 5, graph becomes 0, y becomes 0, it will pass through this. And therefore, somewhere you will get the point of maxima also somewhere. Therefore, the graph is complete. That is what is the nature of the graph. I am not writing the numbers, but you are required to write it. Now, the variation that I would like to do here is, here, suppose this A, B, C and D. A is smaller than B, is smaller than C, is smaller than D. That is how we have arranged. Now, problem number 8. If I just flip these two brackets, y is equal to x minus 1, x minus 5 upon x minus 2, x minus 6. So it was A, B, C, D. Now I am making it A, B, C, D. This problem is like this. Right? Now this problem is like this. Okay. So how will the graph look like? Spend some time and sketch it. So the nature of this analysis is exactly same. Nature of this graph is going to be like this. सांगा जरा माझ्याकडे काढलेलं नाहीये. Y axis, x axis, 1, 2, 3, 4, 5, 6 at 2 dotted line, at 6 dotted line. I think it goes like this. For what value of x it becomes 0 between 2 and 6 is 5. Barabar hai na? 5, if x is equal to 5, y becomes 0. So the graph goes like this. it passes through this and goes like this. That is middle part, smooth. Then it goes like, what is the asymptote? 1, na? So it is going to go like this for greater than and for less than 2, it is going to be asymptotic and passing through 1 and going it like this. So essentially the nature of this curve is going to be like this. So we have done this. We have done this. Now problem 9. Let us take reciprocal of 7. X minus 1, x minus 6, x minus 2, x minus 5. That means we are now doing this. So we have total 4 types, and if we know the nature, our job will be very quick eventually. This kind of questions have already come in IIT exam. Paragraph. I mean, they will give you function like this and ask several questions. What is the local maximum? Is the function differentiable? Etc. Kind of 3-4 questions on paragraph you may end up getting on this. Okay, the nature of this is exactly similar to 7 but upside down. 1, 2, 3, 4, 5, 6. At 2 dotted line, at 5 dotted line, at 1 dotted line. Graph is going to be like this, and like this. Okay, I'm not getting into details. You can always do it. Next, 10. We have done it like this. Now we are supposed to do it like this. 10. Y is equal to, we should start the smaller one in the denominator. Then x minus 2, x minus 5, x minus 6. Now you should have reasonably good speed to finish these activities. Now, graph number 10 is similar to graph number 8. Again, critical points 1, 2, 3, 4, 5, 6. Asymptotic at 1 dotted line, at 5 dotted line. It was graph number 8 had all tangents with negative slope. Graph number 10 will have all tangents with positive slope. Again, asymptote at x is equal to 1, and therefore it is going to be like this. Asymptotic, asymptotic. You can find out where it is going to intersect. Where it is going to intersect between 1 and 2, it will intersect at 2. And it will, when will, this is 6, it will say at x is equal to 6, it is 0. This is the nature of 10. So these are the 4 patterns that we can have, and these are the 4 different graphs. So you should do it very quickly now. Now, as far as this zigzag pattern is concerned, there is no question of maximum minimum. Only you need to find out the asymptote. In case of problem 7 and 9, you have maxima in 7 and minima in 9. You have to find out that. Okay. So the next problem is 11. Variable line is passing through a comma b. Then what happens? Then it intersects x-axis at A. And y-axis at B. Question is, find the minimum area AOB, where O is origin. Find the minimum area of triangle AOB. It is a word problem, but I am giving it now because I expect you to draw some graphs for solving this problem. Okay, we will sketch the area function and find out all the details about the minimum area, maximum area, what kind of function it is going to be, how the graph of that function will look like, and then answering these questions will be very easy. We will do it in the next lecture.